For this problem, we're given a system of two equations, equation A and equation B, and we're asked to solve this system by graphing these equations. So we're seeking the points of intersection of these two graphs, because the points of intersections are the ordered pair solutions that these two equations have in common. Well, we're going to do this by graphing and searching for the point of intersection. So let's graph the first equation A. That's the equation x plus 2y equals 4. Let's find the intercepts to graph this. Let's find the x-intercept by letting y equals 0 in the equation. We get x plus 2 times 0 equals 4, so x is equal to 4, and that means the ordered pair 4, 0 is our x-intercept. Now we'll find the y-intercept by letting x equals 0. Remember, it's always the opposite variable that you set equal to 0 when you're looking for an intercept. So we're finding the y-intercept by letting x equals 0. That gives us 0 plus 2y equals 4. So 2y equals 4, which means y equals 4 halves, which is 2. That means the ordered pair 0 for the x position, 2 for the y partner, 0, 2 is the y-intercept. Now we're going to take a y-axis and an x-axis, and we're going to graph these 2 points. We're going to graph the x-intercept 4, 0 and the y-intercept 0, 2, and we're going to connect them together with a straight line as carefully as we possibly can. Okay, that's the graph of the first equation, which we call equation A. Now let's graph the second equation, y equals x plus 5. That's named equation B. To do this one, let's notice that it's in y equals m times x plus b form, which implies the slope m, which is rise over run, is equal to the number multiplying x, which is 1. We write that as 1 over 1. And the y-intercept is 0b. The b value, comparing the y equals mx plus b equation to our given y equals x plus 5, we see the b value is 5. So the ordered pair 0b, in this case, is equal to 0, 5. Once again, the slope m was equal to the number multiplying x. It was the invisible 1 that was multiplying x, so the slope is 1, which we wrote in the form of an equation 1 over 1, rise over run. And then the y-intercept is the ordered pair 0b, where b is the last number after the x. It's the number 5, so it's 0, 5. So we're going to graph the point 0, 5. We know it lives on the graph of the equation, so let's graph 0, 5. And that's up 5 units. There's that point. Now we're going to use a slope like a road map to find a second point. There's 2 ways you can interpret this 1 over 1. You could interpret it as rise 1 over run 1. That would be rise up 1 over run to the right 1. Or you could write a negative sign on both the top and the bottom, because that's the same as 1 over 1. Negative 1 over negative 1 is the same as 1 over 1. Now you interpret that as meaning rise down 1, then move to the left 1 because of the negative signs. Since our graph is small and it's easier to move down instead of up, we're going to use the negative 1 over negative 1 interpretation. Starting with your pencil on the one point that we know lives on this line, 0, 5, we are going to move down 2 units to 4 and then to 3, and then we're going to move to the left 1 unit and connect that. We're only moving down 1 unit down to 4 and 1 unit to the left to get our second point, which we connect with a straight line. So we connect the 2 points together and got line B. Now, the solution to the system is the point of intersection. I drew the upside down cup for the word intersection. Okay, we're going to try to carefully read what that point of intersection is. If we did this perfectly, we could see the x-coordinate corresponds to -2, while the y corresponds to 3. That means the ordered pair xy equals -2, 3 is the one and only solution to this system. Now you will notice there are finitely many solutions. There are solutions. It's not empty set. There are solutions to this equation, so you know it's going to be consistent. It's only inconsistent if there are no solutions. So this is definitely consistent. And because there are countable many solutions here, there's finitely many solutions, the system is independent.